Okay, so continuing with 4.5, we were talking about our imaginary zeros. And it says find all the zeros of f of x equals x to the fourth plus 2x cubed plus 4x squared plus 2x plus 3, given that 1 0 is I. Okay, the fact that they give us that 1 0 is I lets us know that we can create two factors, correct? So the two factors that we can create are x minus I and x plus I, correct? Okay, from there, I can simplify and find out what this would be, right? So this equals x squared plus 1. Does that make sense?
Plus 1.
When we go through and FOIL, we get the negative I squared, and it makes it a positive 1, right? So after you go through distribution, this equals x squared plus 1. Okay, because this isn't a linear situation, we cannot just do synthetic. We have to actually do long division in this case. Does that make sense? Okay, so we have to do long division. Okay, so with long division, I'm going to set this up. I have x squared plus 0x plus 1. Why did I put 0x? It's a placeholder. I'm missing that. Divided into x to the fourth plus 2x third plus 4x squared plus 2x plus 3. Bless me. And now we're going to divide. Yeah.
Plus yourself.
I've done it my whole life. Yeah. Here we go. X to the fourth divided by x squared. What is it? X squared. So we divide, then we multiply. So x squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times 1x is 1x squared. So we divide, multiply, subtract. When we're subtracting, that means we're changing signs and combining. So I'm going to subtract. These cancel out. I'm left 2x cubed plus 0x squared is 2x cubed. 4 minus 1 is 3x squared. So we divide, multiply, subtract, and now we're going to bring down. So we're going to repeat. I'm going to change my colors. So now I'm asking myself, what is 2x cubed divided by x squared? 2x. So positive 2x. After I divide, we multiply. 2x times x squared is 2x cubed. 2x times 0x is 0x squared. 2x times 1 is 2x. Okay, so now we multiply. We're going to subtract, which means we change signs and combine. Change my signs. Combine, combine, and then combine, and I'm left with 0x. And then bring down. Last go around. What is negative 3x squared divided by x squared? Negative 3. Now we multiply. Negative 3 times x squared is negative 3x squared. Yes. Oh, I lied to you. Yeah. She doesn't know where you got that from. What were y'all seeing? I see positive the entire time. Yep. Then 3 times 0 is 0. And 3 times 1 is 3. Now we subtract, which means we change signs and combine. And everything does what? Cancel out. So that means our quotient is x squared plus 2x plus 3. Okay, that's our quotient. To find our zeros, we have to factor that. So this is a mental factor. So I ask myself, what multiplies to give me 3, but adds to give me 2? A positive 3 and a negative 1. 3 minus 1 is 2. 3 times, that didn't work. Doesn't work. Does that work? No, we don't get that negative. Ooh, what does this mean? Huh? So if mental factoring fails us, we have to do quadratic formula. Now sing it with me. Here we go. Ready? X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey. So did mental factoring help me? No. It was a loser. So we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. These are easy numbers, guys. This is not bad. Negative 2 plus or minus. What is 4 minus 12? Negative 8. We get negative 8 over 2. How do you simplify negative 8? Square root of negative 8. It wouldn't be I8 because 8 is not a perfect square, is it? 8 is not perfect, but it is made of a perfect square, right? So I can take the square root of 4, but can I take the square root of 2? No. So when I'm simplifying this, it becomes 2i square root of 2 all over 2. So this quartic function has no real zeros, only all imaginary. So our last set of imaginaries are going to be 1 plus or minus I square root of 2. And how did I get it down to that? I divided everything by 2, all the terms by 2.
Is that a 2 inside the square?
Mm-hmm.
Okay.
Is 2 a perfect square? No. So when you're breaking down numbers, you only can take a square root of what they have as perfect, right? The rest has to stay at home. So that's our final solution. And it says, what are all your zeros? So these are my last two. And the other one we found instantly, which had to be negative I, because remember, they travel in pairs. See, if they had just made this a -3 for us, would we have had to do that? No, we would have had real solutions, but because it's a +3 at the end, instead of a -3, we do not have real solutions. It just basically means that this is a W floating in the air. All right, we just have a couple more examples of just solving, getting it down. This one is an example of solving by grouping or trying to solve by grouping. But the main thing is that it has to equal 0. You want your leading term to stay positive. So even though you're inclined to move it here, it's better to move everything towards your leading term. So we're going to have x cubed minus 2x squared plus 5x minus 10. And this is where we're going to use the reverse box. It's the reverse because we have our inside, but we need to find our outside, right? How did we get there? So we have x cubed, negative 2x squared, 5x, and negative 10. What's the GCF here? First row? X squared. Second row? First column? Last column. Perfect. So this factors breaks down to be x minus 2 times x squared plus 5. How do we feel about reverse box? Now to find your solutions, you're going to set each factor equal to 0. So we have x minus 2 equals 0, and we have x squared plus 5 equals 0. So our first solution is x equal 2. Our second solution, we have x squared equals -5. Take the square root. So x equals plus or minus I square root of 5. Which means that there's two solutions, right? A positive I square root of 5 and a negative I square root of 5. Remember, that's the plus or minus is just a condensed way of writing it. But these are your actual zeros. So I have one real and two complex. Cool. All right, I don't know how many more examples I did. Oh, just one more example. Importance of factoring. Yeah. This example is an importance of factoring. So we have x to the fourth plus x to the third plus x squared equals 0. Before you do anything and make problems harder for yourself, the number one thing you need to do is check for a GCF. Is there a greatest common factor here? X squared. I can divide everything by x squared. So I factor out x squared, and I'm left with x squared plus x plus 1. Equals 0. So we get x squared equals 0. So we know x equals 0. However, this one I have to factor. And if I can't mental factor, what does that mean? I have to do a little quadratic. So is there anything that multiplies to give me 1 but adds to give me 1? Not possible. So that lets me know that I need to do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay. So we get x equals -1 plus or minus the square root. What is 1 minus 4? -3. So x equals -1 plus or minus I square root of 3 over 2. And those are my last two solutions. Even though I only see 3 solutions, that's because x equals 0 has a multiplicity of 2. And that concludes our 4.5 notes. Okay, I tried to give you a variety of possible problems, but unfortunately, there's like a lot that it could be done, right? Because there's so many numbers, so many places, so many variables. But I'm giving you a variety to check for, skills to look for, greatest common factor, see when you can do reverse blocks. If mental factoring doesn't work, then your good old friend quadratic formula is going to always be there for you. Okay, and if you don't like doing mental factoring or reverse, well, you got to do the reverse, but quadratic formula is always going to work. It's your catch-all, okay, when it comes to a quadratic. All right, the rest of the period is for you to work on your 4.5 assignment.